Okay, so we're going to do example 2 and then example 3 in separate videos, just because I can only do a certain amount of time for each video before it cuts off. So there's a ABC, right? Y equals ax squared plus bx plus c, just like when we were factoring. So a is the number in front of x squared, b is the number in front of x, and c is the constant, the number by itself. So I'm going to write it over here. A is going to equal 1. B equals negative 6. Notice I didn't say negative 6x. I didn't say 6. It's negative 6. Make sure you include the sign. And A, B, and C are just going to be numbers. And we're going to use these to plug into our equations. So C is 12. A, again, is the number in front of x squared. We know it's a 1 if we don't see it. And then in front of x, it's negative 6. So B is negative 6, and C is the constant, the last number in this case, which is 12. Okay, so again, we're going to focus on finding the y-intercept, the axis of symmetry, and the vertex today. And then later we'll practice other things. We'll slowly build on. So for the y-intercept, we know that the y-intercept is 0, c. Remember, to find x and y-intercepts, you just plug 0 in for the opposite variable. So if I want a y-intercept, if I plug 0 in for x, the x terms cancel and you're just left with the last number. We would be left with 12. That's why it's, which is the c value. That's why you can say 0, c. So our y-intercept is 0, c, or 0, 12. And if you look down here at our graph, this time I didn't cut off the x-axis, it looks like we're counting by each big line is a 2 in this case, so it's like 2. If I add 2 more, the next big line's 4, add more 6. So that's why it kind of gets cut off. But if you continue this graph way up there, it's not really accurate because I have arrows. I just did a screenshot of part of it. It would touch the y-axis like at 12, wherever 12 is, okay? So on the y-axis, that would be 12. And that would be our y-intercept. It would be at 0, c, or 0, 12, where we touch the y-axis. And again, just notice the scale in this image that I copied, took a screenshot from Desmos. It was like 2, then 4, then 6, based on how far zoomed in or zoomed out you go. The scale will kind of look different. Okay, now remember also, it doesn't matter how you choose to count on the x or y axis. You just want to make sure that you're consistent. So if on the y-axis I choose to count by 1s, it should say 1, 2, 3, 4, 5, 6. If I choose to count by 2s, it should say 2, 4, 6, 8. And then if on the x I choose to count by 5s, it should say 5, 10, 15, so on and so forth. Okay, so just be careful with your scale if someone gives you a piece of graph paper and they've already, chosen a scale for you. So the second step, we're going to find the axis of symmetry. The formula for axis of symmetry, again, is negative b over 2a. So in this case, we know that a is 1. We know that b is negative 6. So we're going to be using those values when we go to plug in. So for step 2, to find our axis of symmetry, I just write AOS, axis of symmetry. It's x equals negative b over 2a. Notice where there were variables, I put parentheses. I like to, again, put the negative on top instead of in front. It, I don't know, helps me. I don't get as confused. So then, I'll use green. So then on top in the b slot, it was negative 6, right? See how in parentheses, I don't just write a 6. I write negative 6 because inside parentheses, we're plugging in b. So whenever you erase a variable, you want to put parentheses around where the variable was, and then you insert that number. Okay, so pay attention to the top, okay? Some people just put in 6. Okay, and then wherever we had a, We erase, we put parentheses, and we insert that a value, which was a 1. Okay, on top, so double negative turns positive. So I have positive 6 over 2 times 1 is 2, so I get out 3. So my axis of symmetry is a vertical line, right? X equals 3. So notice if we look at this graph, our axis of symmetry, our vertical line is at 3. And notice based on the scale, if this was 2 and this was 4, then this is 2.5, this is 3, right? So x equals 3, our axis of symmetry. Vertical line, right? Okay, so next up, we're going to step 3. We're going to find the x coordinate of the vertex. It's the same as the x value, the axis of symmetry, right? So we know that the x coordinate of our vertex is going to be 3. And again, if you haven't already found the axis of symmetry, to find that value, you still do negative b over 2a. So if you hadn't already found axis of symmetry, the x coordinate of the vertex is negative b over 2a, which is 3. It's the same as axis of symmetry, right? So that's why I like to do it in this order. Then, so step 4 is to find the y coordinate. So if x is 3, right, to find the y coordinate, do blue. So function notation is used, f of x, to show someone what you're plugging into the x slot in your equation. So this is telling someone that we're going to plug in 3 wherever we see x in our equation. So if our equation is x squared minus 6x plus 12, wherever I see x, I'm going to put parentheses because we're about to plug in 3 to see what our output is when we plug in 3. Okay, so wherever I saw the x, I put parentheses and I plug in 3. Okay, PEMDAS, so we have to do our exponent first. So we have 3 squared, which is 9. And we look at that, so I'll write minus 6 times 3. I'll do this slowly. Just be careful, a lot of people mess up with their order of operations. Okay, next up, you've got to do order of operations. Again, I just said a lot of people don't follow order of operations and they get the wrong value for their coordinate for the vertex. So if I do a different color, if I do PEMDAS, right, I'm not doing 9 minus 6 first. I have to do negative 6 times 3 because there's multiplication in there. So negative 6 times 3 is negative 18. And then we bring everything else down. And I recommend moving slowly so you don't make a mistake. Okay, then next we move from left to right, addition, subtraction. So 9 minus 18 is negative 9 plus 12, which would get us 3. So that's our output. When we plug in 3 for x, we get out 3. So our vertex, write V for vertex. Our vertex is the ordered pair 3, 3, which is right here, right? Remember, f of x is the same as y. So the y value is going to equal 3 when we plug in 3 for x. So here's our vertex. Remember, they're counting by halves. So this is 3, 3. Over here, I know the y value up here is 3 because it's 2, 2.5, 3, 3.5, 4. Okay, so this is our vertex again, 3, 3. Okay, so we found all the things we need. We found our y-intercept was 0, 0, c, or 0, 12. And then we found that our, so you plug in 0 for x and you simplify, but when it's in standard form, y equals ax squared plus bx plus c, it's always 0, c. Our axis of symmetry was x equal 3. It sliced through our vertex, which was at 3, 3. That's all we're doing for today. Finding a y-intercept, axis of symmetry, and our vertex. And later we'll practice finding other ordered pairs to draw this parabolic shape. Okay, I'm going to stop this and I'm going to do one more video because we have one more practice problem before you try the homework.